We're sticking with new features that have come along in Entity Framework 7, and this week we're going to be looking at the idea of JSON columns. Now, this is an idea that has come into databases over the last few years, not available in every relational database, but certainly available in SQL Server, which is what we're going to be using. But although it's been available in databases for quite a while, it's only in Entity Framework 7 becomes something we can directly access through Entity Framework. Now, the example I've got here is actually something that reminds me of a piece of work I did years ago, back in the 90s, when I was working on a weather forecasting system, which was essentially just a big geographical information system. And so what we had is lots and lots of data with pairs of latitudes and longitudes representing points on the outlines of countries or islands or whatever it is we wanted to represent. And originally this was all stored in a file system, and it was decided that we were going to transfer all our data into a relational database. And when it came to this idea of coordinate pairs, turned out it's completely unsuitable, because a pair of coordinates is not an isolated bit of data. It only makes sense in the context of all the other coordinates for the particular shape you're trying to describe. And so in fact we didn't end up putting that in the relational database, because you can't traditionally have arrays in a relational database. And that's another nice thing you can do with these JSON columns. So let's take a look at the very cut down example of that I've put together. And what we've got here is we've got a web API application, and then in my entities I've got this idea of a country. So this is just going to be a very simplified version of a country that we can represent on our geographical information system. And it's just a fairly normal entity. We've got an ID, we've got a name, so we can say what country we've got named, and then for the actual data of how it's going to be represented, we've got this class I've called fill area. And if we take a look at fill area, things now are getting a little bit different, because this, although it's going to be stored in our database, does not have an ID, and that means it's not going to have its own table with its own columns. It's going to be storing things actually in the countries table that we're going to generate. So there's our fill area, and all we've got is a couple of things. We've got a color, so this would be the color that it's represented on a map, so we can see different countries in different colors. And then it's got this list of coordinates, and here is where we've got the coordinate data. So a coordinate I've just quickly thrown together as a record with a latitude and a longitude. And so we've got a list of those in our fill area. And in terms of C# code, that's a pretty straightforward way of doing things, to have a country that contains a fill area that has something like a color, and then this list of coordinates. And then what I've done in the program here is I've set up this map context that we'll have a look at in a moment to use SQL Server. As I say, this doesn't work on all databases, but it does work on SQL Server. And then I've got this create DB where I do the ensure deleted, ensure created, so it regenerates every time we run the application. And then I'm creating just a few countries. So we've got here the outline of the UK, the outline of the USA, the outline of Australia, and the outline of India. And UK is in red, USA is in blue, Australia also in blue, India in green. Doesn't matter very much, and obviously those coordinates are very minimal, and it doesn't really matter what the values are. We're not going to be drawing these things, we're just using them as some kind of data. So that's what we've got there. And then, as I mentioned, we've got our map context, which at the moment is just what you'd expect in any use of entity framework. We've just got the DB set of countries. Remember, the fill area and the coordinate are not going to have their own table, so they don't need to be mapped like that. Problem is though, if I run that up, we'll immediately get an error basically saying the entity type coordinate requires a primary key. So we saw we didn't have an ID on that. It's just not going to work if we have it all done that way. So that's where we've got to put a bit of extra work in there. And we do this in our DB context, and we're going to do it with the Fluent API. So I'm going to override the on model creating, and then in there I've got to do a little bit of extra work. I say model builder dot entity, and then the only entity we've got in this case is that country, so that's the one that is going to have the table. And then on that I do this dot owns one, and on that I'm now going to say that what it owns, and we do this with lambda. So the lambda parameter I'm just going to call country, and then I say here country dot shape. So the shape was the property name, remember, that I'd given to this fill area. And so that is now saying that the shape is not going to be a table in its own right. It's going to be embedded within the country table. And in fact, as far as that goes, that is something we could have done before. That's not yet got this idea of that being stored as JSON. It would just be embedded, and all the columns of shape would actually be columns of the parent country. But that's why we're going to do a little bit more here, because what we then have to add is a second parameter on this owns1. And here we can say builder. So this is of class owned navigation builder. And then we're actually going to need a couple of things in here. So I need to give it a body. But first thing we do is we say builder dot ToJSON. And that's the new bit. So if we do that, then that is going to say not only should shape be part of country, not a separate table, but it should be a column that stores that information as JSON. And if we just had this one level of embedding, that would be fine. But remember, we've got two levels because we've got the country containing the fill area, the shape, but then the fill area also has this list of coordinates. So we've got to do that by going down one further level. So also on this builder, we do a builder dot, and this time, rather than doing the owns1, we do the owns_many. So the owns1 was because a country had a single shape, but the shape has multiple coordinates, so we do the owns_many on there. And then again, same sort of thing, we've got to say shape and then just select shape dot coordinates, and that is what tells it that we're going to have the coordinates on there. We don't need to repeat ourselves to say that it's going to be JSON, because once we've said here that the shape itself has to be JSON, then it just works out that the coordinates within the shape are also going to have to be JSON. So that's the key bit to what we're doing here. We've got to have the owns1, we've got to have the ToJSON, and then carry on down through the hierarchy as deep as that's going to go with either owns1 or owns_many, whatever it's going to be. And so now if we run that up, that's actually run up. We've got the Swagger for it over here, but let's not worry about that for the moment, because what we want to do is actually look in the database. So if we go into databases, there we can see what we've just created, that JSON columns EF7. And if we look inside there, look in the tables, it's just got the one table called countries. But if we take a look at the content of that, then you can see it's got what we expected. So remember, we went for the 4 countries. So ID and name were just regular properties on the country class. So they just get dealt with in the usual way. But then the shape was our JSON column. And so we can see on there, let's just open that up. It's a bit cluttered, but their shape, we've got the color as red, and then we've got the coordinates, and we've got the array of coordinates in there. And if we say copy that, and then in here, let's just have a new file and go for a JSON document and pop that in there. Then we can see it's just done a bit of formatting, and we can see that rather more neatly as the JSON representation of what we've done. So that's pretty neat. Obviously, it's still just a piece of text, it would seem. That's what JSON is, but we have got that in the database. If we just take a look at the design for that, so click on design, then we can see that all it is, as far as the database is concerned, is just, as I say, a piece of text. We've got this nvarchar max, and that's containing all of that JSON. But once it's in there, as you might expect, we can now just use that in Entity Framework like anything else. So if we now take a look at what else I've got in here, I've put in just a single controller. There we're injecting the map context, and then to start with, I've just done a get all, so we just get hold of the countries, and that's what gets returned. And if we go to the Swagger and we can test that, so try it out, click execute, and there you can see we're getting our 4 countries, UK, USA, Australia, and India, reconstructed with their lists of coordinates on there. Now, the thing, of course, about that is, because this is a web application and we're returning this data to the client, it's been converted to JSON anyway. JSON all over the place. But don't get confused about that. It has gone through the phase of actually being restored as objects. Because if I put a break in there and just re-execute that function and we hit the break, there we can see the results, and it's an array of 4 countries, but then a country contains a shape, and a shape contains the color and the list of coordinates, and then the coordinate has got those values. So the objects that we get in the program's memory are just ordinary C# objects, even though part of the data has been reconstructed from actual columns like the name and the ID that we had in the relational database, but part of it, the fill area and the coordinates, have been reconstructed from the JSON. And it's invisible to us once we've done that configuration in the map context. The actual storage, which we had at the beginning there in the main program, and the reconstruction just happens automatically with very little work for us. But there's more we can do than that, because obviously when you've got data in a database, what you want to start doing is querying it. So to actually be able to filter it down based on not just the information in the regular database columns, but also what's going on in that JSON column. So let's do that. Let's actually put into our controller a couple of endpoints to show these two slightly different things. So the first one I'm going to do, let's do a bit of copy and paste, is let's have a get country by name. So we'll do the HTTP get, and we'll just call this by name, which will take a name as a parameter, and then we'll call it get by name, and takes the name as the parameter. And then what we'll do here is we'll just change this to context.countries.where, and then C for country gives c.name equals name. So perfectly straightforward query there. And remember, the thing about that is name is just a regular column that we have on our countries table. Whereas the other one I'm going to do is we're going to get by color. So call that color, call that color, call that by color, call that color, and then here we're going to say where c dot shape dot color equals color. So again, in terms of C# using LINQ and using Entity Framework, nothing particularly special in there. And if we run that one up, then we can see our 2 new endpoints. And if I go for getting a country by name, then that's got the UK. If I go for getting a country by color, then that's given us the USA and Australia, because I had both of those with blue. So both work perfectly fine. However, if we look at the SQL that's been sent, we can see it's rather different. So here we've got the one that's getting it by name, and that, remember, was just the regular column. So we just have where name equals and then the name parameter. But then here, when I wanted to get the color, which was part of the JSON data, so that, remember, the color was embedded into the JSON. It wasn't actually a column, but it does the same sort of thing, but it has to do this bit of extra work. So on the where clause there, it has to extract that JSON value, cast it to a string, and then compare that to the color. And that's the way that it's been done for quite a few years in SQL Server since JSON columns were introduced. But what's new is the fact that LINQ to Entity Framework can now generate that appropriate SQL to do the job for us. The other thing to notice that's happening in all these queries, to return the data, it's got to do this JSON query as well, just to get hold of that shape column. But again, that's hidden away for us. And so that's really nice. That means we can just write the code, really oblivious to how this is actually being stored. So we can just do a query on ordinary data or a query on JSON data. That's going to work fine. Now, something else you might think it'd be really nice to do here, and you'd be right, it would be nice to be able to do it, would be if we could actually not just filter on the basis of that color information, but actually get into the coordinates and filter on those values. So what if we could have something like this? Let's have another HTTP GET. And what I'm going to do here is call this above latitude. So what I'm going to do here is have the ability to select any country that has any coordinate greater than a certain latitude. A little bit of an odd thing to do, but it will just show what's happening here. So we'll make that latitude a double, and then let's put above latitude in there, double latitude, and then countries where, and then what we're going to do is do c.shape.coordinates.any, and then where co for coordinate, co.latitude is greater than the latitude that's been passed in. Okay, so that should give us back any country that has any coordinate whose latitude is greater than the value we've passed in. So that's straightforward link to put that query together. But if we run that one up and try to do that above latitude, so let's do anything above the equator, say, so latitude of 0, then we get this rather nasty error. And it's showing us that link query, which compiled perfectly well. If this had just been linked to objects, if that had been just in memory, it would have worked fine. But what it's saying is it can't be translated, so it can't generate the SQL to enact that query. So it's saying either rewrite the query in a form that can be translated, not very helpful because it's not telling us how to do it, or switch to client evaluation, inserting a call to as enumerable or something like that. Now we could do that. It's not a brilliant idea to do that, but we could. So all we need to do in here is put in something like a dot as enumerable, and then we don't have the toArray async on there, so we'll just whip that off and whip that off. Don't worry about the warning, it's because we've got the async, but I'm not going to have this for long. So if we run that up and do the same sort of thing, then we can see that that works okay, and it's given us the UK and the USA and India as the countries above the equator, and then obviously Australia is the one it's missed off because that was below the equator. But if we look at the generated SQL from that, we can see it's not been very clever at all, because all it's done is selected all the countries without restriction. So doing it with that as enumerable simply pulls the countries into memory and then executes the link query in memory. So Australia was pulled in and then rejected in the program because it wasn't wanted. And that's a typical sort of thing you want to avoid with Entity Framework because it can be very inefficient. If we'd had 10,000 countries, only 4 of which met this criteria, that would have been a lot of data pulled into memory. So it's a solution, but it's not a great solution. And the fact is, when we're looking at this, the problem is not that you cannot query something like a coordinate in a JSON column. It's that Link to Entity Framework does not have the ability to translate the link into the appropriate SQL. But we can actually write that SQL. So if we go to SQL Server Management Studio, and let's in fact modify the query we've got here. So we don't need the top 1000 because we're not getting anywhere near 1000. So we want the name, the ID, and the shape from all of that. But then what we do is we use a SQL Server term cross apply, and then we have in here open JSON. So I'm not going to go into depth in these because this is really off topic. It's not the C#, it's the SQL, but it just shows what we can do. And then here what we have to do is we select that shape column, and then using this open JSON, we can select from within it the coordinates. So we say $.coordinates is what we've got there. And then we say with, and then from that coordinate, we select the latitude. So I say latitude, we define it as a float because that's the equivalent of a double in SQL terms. And then again, from the coordinate, we pick out the latitude. And then we have to give that a variable name that I'll just call lat, short for latitude. and then we say where, and then this is where we actually do the filter. So we say lat.latitude is greater than, and then let's just put in, again, 0 for the equator. So we're saying what we want to select, and then we do this cross apply, which is a bit like a join, but onto the JSON data. Then we have to extract the particular bit of JSON data that we want, and then we apply the filter. And if I execute that, then you can see that it has done it, but not quite what we wanted, because what's happened is when we look for coordinates with latitude greater than 0, when it comes to the UK, well, all 4 of the coordinates for the UK are greater than 0. Therefore, we're getting 4 instances of UK, and then we've got even more for the USA, 4 again for India. So the problem is it's giving us back the country multiple times because it's got multiple coordinates. So all we need to do on that is do a distinct, which tells us we only want 1 copy of each row coming back. And when we execute that, we get the answer we wanted. So that has now filtered us by the countries that have at least 1 coordinate that has a latitude greater than 0. So it's possible to do that in SQL Server, but as yet there's nothing in Entity Framework that will allow that to be translated from our link that I've written previously. It's to be hoped that in future versions this will come through, but at the moment it's not there. But we can still put it into our program. We've just got to issue the SQL directly, which is something generally you want to avoid when you're programming with Entity Framework, but we're going to have to do it here. So let's put that in. So what I'll do is, in this one, I'm going to say results equals, and then underscore context dot countries. But this time I've got to say from SQL. And this is nothing new, but this is how we can issue SQL directly in Entity Framework. And then what I'm going to do is I'm going to use string interpolation, and I'm going to use one of these raw string literals that we talked about in a video a couple of weeks back, another new feature that we've got in C#11. So that means that we can just have this thing split over multiple lines that'll make it a bit more legible. And then let's grab hold of the query that I had there and pop it in between the multiple lines so we can see that's what's going on there. Just make it a bit more legible in terms of how it's written out. Then of course we've got the problem we need a parameter in there. So what I'm going to do is create one of those. So we need to say var, and we'll call this lat param, and then that equals, and then we've got this thing called an SQL parameter, and we give that a name, which I'm going to call latitude, and then give it a value, which is going to be the latitude that we've passed in as the parameter there. And then because I've got this as an interpolated string, I can simply down here put in the lat param. But doing it that way is going to mean that we avoid any risk. There's not much risk here anyway, but it completely avoids any risk of something like an SQL injection attack or something like that. So that's going to be what we have there. And then finally, the last thing we've got to do on that is our results at the moment is going to be a queryable. So we've got to do a toArray async. And then also, obviously, we've got to await that. And so that should sort things out. So in this case, that will now do our query correctly. So if we run that up and go for our latitude, and again, put the 0 in there, then you can see we're getting the UK and the USA and India. But if we look at the generated SQL this time, we can see that basically there's the query that I sent out. You can see it's done a proper parameter for that latitude, so no risk of an SQL injection attack. And then it's wrapped that up in this further select, because that's what then is taking the data and is going to, underneath the covers in Entity Framework, put that into our objects. So we can see that we can make that work. So fairly straightforward what we've got there. I would imagine that in future versions of Entity Framework, it will be able to generate that quite complex bit of code for looking in an array. But for now, it's not possible, though it is possible, as we saw, for it to do things like looking at a single item inside that JSON like we had with the color, so that was working okay. But the key thing that we have to do is pretty simple for this. It was what we did in the context. So we've got to do this owns one or owns many, and also we've got to do this toJSON so that that will map correctly onto the JSON column. So that's quite a nice new feature, allows us to mix together two styles of data storage, and I can certainly imagine situations like this or lots of others where I will be using that. I suppose, arguably, I should have been using that anyway because it was available in SQL Server, but it's much more accessible now that we've got it available also in Entity Framework. So I hope you enjoyed that. If you did, do subscribe, do click like, and I'll see you next time.